Well, all right then. Facebook is saying I need 100 subscribers before I can go live. So we're on YouTube. And so it is. This is Adam Abraham with the President Water Company. And we're going to add my cohorts. Well, we got a new cohort. Jody Bevan is here from Australia. And we also have Lee Gross, who is here. You know something? Thank you. First time saying this in public. And since I anticipate doing this a lot, better get it right. First of all, and we got the voice. There he is, Lee Gross from Calgary and Ethical Earth Solutions. It is our intention, our desire, and purpose to talk on a regular basis now about vortexing applications. And because water is as ubiquitous as it is, and hold on a second, there is another little detail I've missed out. Hello. Boom. There you are.
Boom. There we
Because
go.
water is so ubiquitous, there's so many applications for it. We oftentimes kind of lose sight of the fact that it affects every part of our life. And so, and I'm saying we, that includes moi, in this sense. There's always something to talk about regarding water. So, what we're going to be doing is getting together and talking the subjects of water on a regular basis. And I anticipate that you're going to find it quite interesting if I hand over this to my cohorts. So, anyway, Lee, why don't you tell us a little bit about Ethical Earth and your interaction with water first? Today, we're going to be talking about water softeners, I think is a topic. But let's start with kind of an introduction.
Well, first of all, hi, Jody.
Hey, Lee.
Good to
Nice
meet
to
you.
meet you, bud.
Yeah, you too. So Ethical Earth Solutions was started back, I guess, in late 2019, just before the pandemic came upon us, and incorporated in 2020 with the intention of focusing on water technologies and starting with electrolyzed water, also known as hypochlorous acid and or electrochemical activation, and or analyte water is another acronym for it. And we got started, and my primary interest was more in the food side, food production, both pre-harvest and post-harvest sanitation. And then COVID hit, and that kind of took the focus for a period of time. And because the product, the hypochlorous, is also a medical grade disinfectant that's 100 times more powerful than bleach, yet safe enough to use around plants, animals, and the environment, etc. So yeah, that was primary what spawned Ethical Earth, and since then we've expanded into other technologies. Obviously, working with you, Adam, at the Vortex Water, and also expanding into ECA generators, the electrochemical activation generators, which are the machines that will produce the electrolyzed water, and then also nanobubble generators, which obviously generators that produce nanobubbles. So that's what's taken us to today, and we're continuing to expand in various water-related technologies, innovative and regenerative water technologies.
Excellent. Excellent. So, you have been introducing the vortex units and as a modality up in different in your area, so to speak, up in Alberta. And what kind of reactions are you seeing so far before we get into talking about softeners and softening?
Yeah, well, I hope we'll touch on reverse osmosis as well as softeners today, because who do have a few questions from clients. So definitely a lot of interest. We brought in 10 of your PW50s, the small half-inch units, and there's been some great response. They're mostly almost spoken for. in less than a week. So it's a great way for people to get started, try out the technology, experiment with the technology, and have their aha moment, as you like to refer to. And yeah, we're rebuilding our website to include all these other technologies. So it's it's a work in process, but so far the response has been great, and people are looking at it in a number of different sectors. I guess I would say there's agriculture, of course, and we're also exposed the technology to a local gentleman who's kind of spearheaded not only the local effort, but the Canadian-wide effort on getting fluoride out of the municipal water systems. And they recently won an EPA lawsuit that the EPA acknowledged that fluoride is actually damaging for children. So, but the question he asked around vortexing was what would vortexing do to fluoride in the water? And of course, you and I had a conversation of that. So, there's a number of different sectors that are potential opportunities that we haven't, had the chance to approach yet. But so far, the response has been great.
Okay. So while I did say that we talk about softeners, I know we had several subjects, but you have prepared questions from potential customers on this other subject, and you got them. So I think we should deal with the questions from them. Uh, so why don't you start? Okay.
Okay.
No
All right.
no objections.
So, yeah, that's great. So reverse osmosis, obviously, I mean, the understanding that, we all have is that it's the most efficient and effective way to, for water filtration, whether it's municipal or even on the farm. It's the most commonly used filtration technology. So reverse osmosis followed by active carbon filtration is the preferred. Equally as good as distilled filtration with active carbon, but working with distilled systems is much more complicated. So reverse osmosis seems to be the way most people are, or what most people are using in many sectors. The challenge with that, of course, is that it removes all minerals, and so there are some, mineral cartridges, depending on the type of system. There are some ways to remineralize that water, but the challenge is that when you take the minerals out or filter the minerals out, that water has a memory, and has certain behaviors, I guess, when those minerals are removed. And so, this is what we want to do a little deeper dive on today, is how vortexing can address that behavior of that water after reverse osmosis has been used. So that's the overview. A specific question. Any response or anything to add to that, gentlemen?
Yeah, I'll have a little say. Look, I've been playing with reverse osmosis systems and selling reverse osmosis systems now for probably 10 years as the primary mode for creating great water. However, like everything else in the world, the devil hides in the details, and there's a lot of claims out there. Let's just talk about domestic reverse osmosis for starters. Pretty much everybody out there that's selling reverse osmosis systems are taking the membrane manufacturers. So you got all the components of the RO system, obviously, but the membrane itself, they take the membrane manufacturers' removal rates and they publish those. Now, those removal rates are created in a laboratory under ideal water temperature and ideal pressure, so you get even pressure across the membrane. And so the removal rates are higher than what's replicatable in what's replicatable in domestic settings, because you've got varying pressure gradients at different times of the day and different times of the week that affect the capabilities of the membrane. And I'll give you an example. What, seeing as you're talking about fluoride, if those reverse osmosis systems do not have an electric pump or something called a permeate pump, which uses the brine water to create a back pressure across the membrane so you get an even distribution across the membrane, then the water, if it doesn't have one of those two apparatuses, the water will find a way through the membrane where it creates a path of least resistance, like a little river. Now, in the tests that I've done, the removal rate, most membrane manufacturers tell you there's a removal rate of fluoride of 93 to 95%. In my experience with the tests I've done, that number drops to 75%, and that's a big percentage drop when you're expecting to remove 93 to 95%, when there's not that even pressure across the membrane. So again, the devil hides in the details, and so it's important that it's important that people know what they're buying. And to be perfectly honest with you, in the water filtration and industry, there is little to no duty of care. People just want to sell you something so they've got an ongoing revenue stream. There's a lot of other bits and pieces we can chat about around RO systems, but primarily that's a big issue with RO systems. And then on to what you said about the your question around resetting the memory of the water and remineralizing the water. There is a lot of options out there to remineralize your water. Let's just address the memory of the water. With my domestic reverse osmosis systems, I run a PW50 after the membrane. In fact, I run the water after the membrane through a zeolite impregnated carbon that pulls out the balance of the membrane, and we take the removal rate from so there's 0.8 parts per million down to 0.016, and I tested that after 6 months. It was 0.016 parts per million from 0.8, which is a 98% reduction. So then I run it through the PW50, and obviously putting it through the PW50 resets the memory of the water, that spin that the vortex device creates, because you're creating a 0 point field that resets the memory of the water. Then we run it through a high quality remineralization process, which includes tourmaline, far infrared, coral calcium, an ORP media, magnetics, and ceramic magnesium. Now there's lots and lots of low cost options out there. Personally, I don't use when it comes to water. I think it's the most important thing we do, other than getting our light right. So I don't go for those cheaper options. I go for something that's NSF certified, and so you're energizing the water before it goes into the remineralization process.
Good solution, the
remineralization.
remineralization.
It's a hard media.
Yeah, I keep thinking about sea crop, Arthur Ziegler's sea crop, as a liquid potential because of its full periodic table of minerals, trace minerals, and ultra trace minerals in the exact ratios that we need them. So
Yeah, look, and I'm a big fan of adding. I still add Baja Gold or Celtic sea salt to my water. Probably 70% of the water I drink. So you know, I'm just all about making the water as good as it can be.
Right.
Given the water that you've got.
Right. So one question that I had from one client, a Hutterite colony, who
Mm-hmm.
purchased one of the PW50s, and the question they had, they told me about a colony close by who has 3,000 parts per million TDS, total dissolved solids, and they are using RO system to filter down to, I guess the right word is filter, but down to 2 parts per million. This
Yeah.
particular colony, where I was, they have 1,000 parts per million TDS that they also are filtering down to 2 parts per million. So you have these two Hutterite colonies, one with 3,000 ppm, the other with 1,000 ppm, both filtering down to 2 ppm.
Yeah.
The colony with the 3,000 ppm has extraordinarily aggressive, what they term as aggressive water. So when I
Yeah.
asked them, okay, so what do you mean by aggressive? Obviously, they're aware that that the water has a memory, and that when you take those minerals out, because they had such a high TDS, that water is aggressive. And their explanation for the aggressive was that it's attacking their infrastructure, their pipes, their pumps, their various pieces of equipment, even after all the minerals are taking out. So it's so that memory of the water, the behavior of the water is extraordinary. So maybe you
Well,
could
I think
comment.
I think that that's obviously they're probably running a commercial system if they're using it for
Farming,
if they're
yeah,
getting
yeah.
it, yeah, and if they're putting it down to 2 parts per million, that water will be super aggressive for two reasons. Um, primarily, it doesn't have any minerals in it, and so when it doesn't have any minerals in it, it it's that water, because it's out of balance. Um, it
It
will
will take
pull
those
in
minerals.
it will pull in carbon dioxide from the atmosphere, which will give it a low pH, and that's what will be upsetting their infrastructure. That'll be eating the infrastructure alive, pretty much,
Hmm.
because of the acidity of the water. It's probably running between 4 and 5
pH, yeah.
pH somewhere. That would be just my guess.
Hmm.
Um, and you know, I've obviously got very very efficient membranes. I would talk to the supplier of the unit to see if they can get a membrane that's not. You can get different membranes with different removal ratings. I would be talking to them about having a 90 or 95% membrane, so you've got um, you know 50 parts per million of total dissolved solids left in the water, and for the guys that
Hmm.
got 3,000, it'd be 150. Um, so yeah, that's
I think
that's their issue.
there's another factor though. When you say 3,000 parts per million, or 1,000 parts per million, and then down to 2 or whatever they're looking for, their purpose for removing them is what? I know
Well,
they're
I guess.
saying they want to remove or reduce total dissolved solids, but see, total dissolved solids it's kind of antiseptic, a sterile term, because they're minerals, right?
Hmm.
You say they call them solids, but they're actually elements. Is that correct?
Jody'd be the one to answer that
Okay.
one.
All right. So if there are elements which actually work with others, the reason for reducing them is I'm going to pose the question, but answer it, at least from my perspective. Okay. The reason for removing those elements or reducing them is because their ability to be utilized has waned by in some kind of way, growing together, and we call it agglomeration. I call it agglomeration, or whatever term, where they are clustering and clustering and clustering. They become not really biocompatible. It can't be used, can't get through a root wall, can't get through even the membrane, because of what they do, and they keep growing, they start clogging up the membrane. So their usefulness has basically turned them into a nuisance, which they simply called dissolved solids. And so my point basically is that, why does that happen? And that has to do with the lack of dynamic movement and coherent movement, which is what a vortex unit creates. So the plants need those elements. They need them available, and they need them in sufficient quantity or supply. And water is the natural, normal medium of transmission of, and trans transportation of those elements to the intended destination. That could be the soil itself. It could be plants, crops. It could be human beings. And so, essentially, the habit of trying to get them out, that's been a coping mechanism to attempt to actually get some value out of this, but you can't. Now, the hunger part of this, they call it aggressive. You basically cut the heart of all of those relationships out of the water volume itself. These are elements that are intended to work with each other under proper conditions. And so what we've done is essentially gone in and cut the heart of those out, so to make it more convenient for someone, and then on the back end want to put it back in. But it is never going to be the way it is intended to do. Vortexing basically allows, through the motion, to restore the coherent relationships. It doesn't take anything out, it doesn't put anything in, but it makes those elements available without going through the trouble, not only of taking them out, but also creating that severe hunger, that severe aggressiveness. Because if you have that situation going on inside of a body, and that water is quote unquote hungry, start drinking distilled water, which doesn't have any minerals and stuff in it. It will take it from wherever it can find, from your bones, from your muscles. It will get what it needs. Water does this wherever it is. So the process of
It's
going
always
through all, I'm
it's
sorry,
always seeking. It's always water's always seeking balance, right? So
absolutely.
if there's no minerals in the water, then it'll take it from where it can get it.
It will
Now,
not take no for an answer either.
no, and the other, if you take it back even further, but before we get to the TDS of 3,000, the reason that often the reason the water's running at 3,000 TDS or 1,000 TDS is because man's tapped that water from a bore or a well before it's made its way through the hydrological cycle, and so it hasn't. So it's what Victor Schauberger called immature water.
Yep.
It hasn't ripened itself through the process of the through the natural processes of what it was designed for before it comes to the earth. It wouldn't have come to the earth by the top, to a spring with 3,000 parts per million of solids, because that's just not nature's way. It's not ready. So what we've done is we've taken immature water, and now we're having to deal with the consequences of that, which is okay. People need water, and there's that. I get it, but fundamentally we've tapped water where it hasn't naturally been designed to come to the surface of the earth.
Okay.
Yeah, the
So
harder
now,
it
would
is.
that all
Go ahead.
go ahead,
Sorry.
Ab? Now, would that also include? I know this one particular colony they drilled. They brought up a special driller who specialized in primary water, drilling primary water wells. You're familiar with
Yes, I
that? Yeah.
am. That's a different thing.
Yeah, and so how does so most wells are drilled into surface water aquifers, right? So
Yeah.
how does it change that dynamic when they're tapping into primary water?
Well,
Uh, okay.
to be honest with you, it's the from where I sit, and I'm not, I'm all I'm doing is sharing the experiences that I don't think anybody in the water industry that's really serious about water. We don't all have all the answers. All I can give you is my observations and my teachings over time. But still, drilling that water, that's not how nature intended the water to get to the surface.
Right.
That's what
Yeah,
it boils
wouldn't
down. That's what it boils
yeah,
down to for me.
Well,
even if it's at the Earth's core, it's not coming through the hydrological cycle, right?
Yeah.
Yeah.
well, primary water is coming from a different cycle, and primary water unto itself is not a bad thing. In fact, it's something very good. However, this is not the source of this bad behavior. When they're talking about extreme, aggression of water, you're not talking about primary water.
Right.
If they are, I'm always ready to be corrected. But I have met a geologist that is prime in the primary water sector. It is promoted. It is purported to exist about three or more times water in the body or belly of the earth than is on the surface, and we're
Right.
talking pristine water. Primary water has its own situation. What this guy is talking about is drilled water, and the
Yes.
deeper it goes, the deeper it is to get it, the less ready it is to be used. Nature makes that which is uh, not ready for prime time harder to get. I recall driving across the Pyrenees Mountains some years ago, and I'm looking at this granite, and the water was like coming out of the granite. When water is ready to show up, it shows up. It doesn't
Hmm.
matter what it is, okay, or where it is. So
Right.
my point, basically, what we're talking about though is this aggressive water, and in fact, uh, this to me, and consider that I'm biased now, all right, but this to me is reason to be vortexing their water, and quite frankly, I would set up a way that they can literally simply vortex that water that has all those elements in them. Stop calling them dissolved solids. This is laboratory talk. These are ways to just sit and have this wall between nature and how we're interacting with it.
Hmm.
If they have that much of a need where they got membranes, and they've got this behavior, that the water is not that it's not getting through the membranes, but it is filling them up, it is clogging them up. This is due to the lack of coherency in the water itself, in the water volume. And that's not simply the water, is everything that is also in the water, called, as far as the elements are concerned, which are normally called dissolved solids, which we have already grown calloused and disconnected from. We need to really reconnect to all of the elements of nature because they're all there for a reason. And once we start to acknowledge that and appreciate their not just purpose for being there, the necessity of them for being there. Because if you don't pull all that stuff out, which takes energy for one thing, it creates a major disturbance. You talk about a hole, an HOLE in in the in the volume and in the relationships. There are electromagnetic relationships that are normal and natural to all of those elements. There are bonds that are appropriate to all of them. And when they are there, they work a certain way, they behave a certain way. When they're pulled out, something else happens. And the Hutterites are seeing this as what they call and describing it as aggression. You stop pulling the stuff out, you stop the aggression. Then, if you, with the vortex unit, which will have this cohering, this orchestrating, this stabilizing effect. See, you got total chaos now. I mean, with the solids, you got total chaos. You have no stability. This is how you get these concentrations and depressions uh, uh, of of associations of elements. And as Jody pointed out, water is always seeking its balance. So the balance is done how? It's through motion. It's already what they're pulling in has already lost its ability to sustain or create balance.
Right.
So by
Yeah.
putting the vortex, go ahead.
So Adam, because I've only got a short amount of time and I've got to take off,
Got it.
unfortunately.
Understood.
You know, what you're saying is 100%, 100% right. However, we don't know that 3,000 parts per million. We don't know what that consists of. Is that
It
2,000
doesn't
parts per
matter.
million? Well, it does. Like it does because if that's 2,000 parts per million of salt and you're trying to grow something, then that ain't going to work for you. So
Sure.
The
Yeah, you got
aggressive
to get.
water isn't working now.
yeah,
My point basically,
so what I'm saying, Adam, is that back to the devil hides in the details. Like you got to know what you're dealing with before you can come up with some solutions. I hear what you're saying in regards to restoring the motion state and making that water, for want of a better word, usable. However, at this point in time, when you say it's just 3,000 parts per million, of what? Because maybe it's a deal where they have to shandy some of the water or change the membrane so some of that TDS gets through.
real real quick, there was a guy named Rustin Roy. He was a material scientist, Penn State University, and other places. And before he passed in 2010, his sermon was that what is in the water doesn't matter. It's the structure of it. All I'm saying is this: we are not figuring it out. You are right. We don't know. The cool thing about this is that we don't have to know. There's certain things we need to know. Yes, there's certain details we need to know. All I'm basically saying is this: based on the experience that he's having, it is worth doing this and seeing what happens. Because I don't know
Yeah,
either. I'm not trying to know everything. There's certain things I do, but there's certain things that nature works out on its own if we get out the way.
that's right. But fundamentally, it comes back down to tapping that water before it was meant to come to the surface of the earth to be
Right.
used.
That's where the problem started.
On that one premise, and what I'm saying is that vortex is super useful, but it's when you're trying to address something to remedy or to bring some more usability or greater coherence to the water so it interacts with people, plants, and animals more effectively, then we've got to study the details. And on that note, gentlemen, I've got to take my young fella to Little Athletics. It's Saturday morning here in Australia, and it's Little Athletics time, so I have to bid you farewell. But thanks for setting this up, Adam. Great to meet you, Lee. I look forward to further conversation, because the more that we can share these sort of interactions, the better off everybody's going to be. It's all about creating a better environment for people, plants, and animals.
For sure. All right, Jody. We will
All
talk
right.
to you
Thanks,
next time.
guys.
All right, now. See you. Thank you. All
Yeah.
right.
Okay. Well, I do have another question here. Let me just pull up my recordings here and just see what I got. Maybe I'll just play it and it'll be straightforward. Here with George Waldner of Grass with asking questions for President Water and Vortex Generators.
Right. So we're thinking piping, and I'm thinking about going flexible piping to eliminate sharp bends like 90s. And I was wondering, if we're not going that route, if we do some PVC or polypropylene, what have you, if a guy goes 45s, will it have half the negative impact that a 90-degree turn will have, or is it proportional that way?
We'll get that question answered.
I'm going to be real practical about this, is that 45 is better than 90. Whatever frictional component, whatever oppositional effect that occurs from a 90 is certainly going to be reduced. One of the things that we say and live is that until we've done things, we start with suppositions and hunches, and some things really we have to see how they look. Things that we just talked about with Jody, clearly we have different ways of looking at something, and it's based on our individual as well as collective experience. So we've got a lot of knowledge and we have a lot more to gain, but we sometimes it's experiences that we haven't had. So to talk in terms of specifics of will it be a linear correlation between a 45 and a 90? I don't know that it would be. My guess is that it wouldn't be linear. I think you probably get more from the 45, or should I say there's less loss from 45 proportionately than from 90. Now, that could simply be my hope. But ultimately, what I love about what we're doing now is we're of a place that more and more people can conceive the question, are interested in the answer, and not only are able, but they're willing. Let's turn it around. Not only are they willing, but they're able to let us strap this together and just see. And then we do the feedback loop. And now we got more and more people who are involved in having actual experiences. Those are the aha moments. And see, on the other hand, we've got years of installations of customers who were doing 90 degrees and 90 degrees, and they were having phenomenal improvements with just that. We had no idea about preserving the curvature, preserving the flow. This is a fairly recent place that we've gotten to where we're talking to people about doing their plumbing in such a way that, hey, babe, man, it's motion. We want to enhance, we want to preserve the motion state because it gets us even more benefit. So that's my take on it. And that would be the way I would look at it. We're all in a learning moment. It's continuing.
Right. Now, I think there's more to that question. Let's.
What else? A straight line, how far? Because you gotta have piping. So how far? Let's say our barn inside the cage area is 300 feet long. Okay. Well, is that too long without boosting it with another one of these inline?
From my understanding, I think what we'd be looking at is flow rates, right? And how much water's flowing through and what the pressures are, right?
Well, in a layer barn, it's very minimal. It's inches of water column, basically, because those nipples are, the birds trigger them, and there's hardly any pressure there, and so there's not a lot of volume either.
Well, we'll get that answered for you.
Now, Very low flow rate. Where's the water coming from? Are they in a holding tank?
Yes, I would imagine there would be tanks outside of the building that would be holding tanks. Yes, I
And
don't know
how
that for sure, but that's my guess. Some of the
and
facilities I've seen like that.
the water is getting into the tank how?
These are questions that one would have to determine. The answers you'd have to determine through doing an analysis. But this particular layer barn is not built yet. It's under construction. But other ones that I've seen do have tanks outside.
And any idea of the line size coming out of the
Not
tank?
Not yet. No, none of that is. I imagine that's on their blueprints and on their drawings, but that can be determined, and maybe we can get a set of their drawings to mechanical drawings.
That's an interesting situation. If the movement of the water through the plumbing system is triggered by the chicks sucking on a nipple, is that what I'm hearing?
It sounds like it. Yes.
Well, then it just means that I could see what he's talking about, flow
Yes.
and a question about it. So one thing that I would be doing in designing this thing, this is free information at this point in time, and take it how you will. But I would be doing something if there is some type of reservoir tank or whatever that is supplying this. And if it's not, I would probably suggest one, and which would give you the opportunity to vortex the water as it's coming out of the tank and now going down into the system. Because every time, because that would actually induce flow, first of all, perhaps a bit more substantial flow than simply waiting for the chickies to do their thing. Although, if you've got a lot of thousands of chickies, that water's still going to move through that system decently.
I think that the intention there is that they can't have much flow because it would be too explosive when the chick opens the nipples. So I think it needs to be regulated downwards. So that's the way I understand it, but we could find that out. But yes, a mixing tank and a holding tank. The ones that I've seen before also have their dosing in hypochlorous or analyte into that mixture as well, which we talk about this a little bit further in the recording. So dealing with bacteria.
It's one of the trickiest places to treat water lines in because it's so low flow, so low pressure. When the birds, when they activate that nipple, it seems like it lets bacteria in better than under pressure situations.
Right. So I would think a combination. So if you are using Vortex, number one, and then a combination of using or electrochemically activated, and you're dosing that into the water supply as well, you really shouldn't have any bacteria problems at all, right? And that's going to, both of those solutions, and that's a pun intended, they're both liquid solutions, but a solution, and they both are going to address the biofilms and the buildup, because it's the biofilm buildup in those pipes that's going to come out in the form of bacteria, right?
We're also thinking of putting on an automatic flushing system. Okay. So that do once a week, it would bypass the regulators, open some valves, and open the valves at the back end, and get a higher volume through there.
So then you would be flushing HCl through those at a higher concentration.
Yes.
Because normally if you're dosing it in, legally under the, say, the Health Canada DIN number for the disinfectant, which I can show you here on our label, right? So that's got a Health Canada DIN number, and I think it's 4 milligrams per liter is what you're legally allowed to feed livestock, for example. Okay. So that's.
I had a thought also about the tank, about an outlet side using some height. Doesn't have to be, I don't know how big the tank's going to be, that would get some velocity for vortexing side, which does not have to be translated into throughout the system from the standpoint of the chickies themselves, but it would tend to keep the level of vortex stability, so to speak, up. Every time those nipples are addressed and activated, it's going to move water through it. And depending on the line size, that is it's never going to be fast, so to speak. I don't see, depending on how much footage it is. You could have, and they were talking about repeaters. You could have PW50s here and there. We've got the our Traveler, which I've got one downstairs, which basically just works on gravity. Water's going to notice any alteration in that would induce movement, so to speak, and then it's going to act on it. So that's going to be an interesting thing. The other thing, this is a new barn, as I understand. You just
Yes.
said what'll be interesting too would be to do some comparisons in growth rates, mortality rates of the chickens themselves on Vortex water compared to existing norms now.
And what data do you have on that so far in facilities that you have installed? So in layer barns or in chicken facilities that you have installed Vortex generators?
We've got a few, and it's really interesting that probably in both cases the people who bought them either were near death or died or something. But yeah, we've got. I think I may have sent you a picture of one that we have. There's on two barns, one on 4,000 chickens, and the other 7,000. And the guy sent me a picture of it installed. And then, like I said, I haven't heard from him. I sent him a text message a while ago, and he's never. This is months ago. Never got that second one. We had another one in North Carolina, same type of situation, and we have something in Australia too, where they're putting on chicken barns, and basically we've seen acceleration in the growth rate of the they call the babies. They grew faster, they were larger, their weights were larger. We have also, some cases, we've seen uh, in the shells. I'll say a normalizing of the eggs, rather.
Mm-hmm.
So I don't know what their
What,
present
and what
experience
about
is.
mortality?
Yes, were improved.
Okay.
So survival rates, whatever you want to say. Ultimately, you got more. It's the same kind of situation with seed germination. Where
Right.
we had my friend down in California, 50% germination rate using local, I don't know if it's spring water or what, but it was from a really good quality place. This is in Mount Shasta. And he took the same water source, ran it through his PW100, and he got over 90%, 95% from the same water source.
Right. So in the, so the chickens though, so, the other points or benefits, what about the birds themselves? As I understand it, they will, actually need to eat less. So, like there would be a reduction in input costs in terms of feed costs. And they're also drinking less, yet they're healthier, as I understand it.
Yeah, and also bigger. I mean, more for the bird.
Right. For the amount
Okay.
of feed that they're eating, they're a
Oh,
larger bird.
and I this was one of my stories before I had more of my own, and this was where a guy put. This was in South Dakota, I believe, but he put a unit on, and the egg production itself skyrocketed.
Hmm.
Whatever there had been, I just 50,000 dozen. They produce a lot more eggs.
Okay.
I mean, egg production went up dramatically simply by adding a Vortex unit on.
Okay.
So these are just some things I have forbidden video, so to speak, because I recorded this guy talking even about his greenhouse and some things he had never seen before, and he is Hutterite.
Hmm.
So
And when forbidden video, meaning that he wasn't comfortable using them
they don't want
public.
my videos on the internet.
Understood. Yeah.
This is years ago.
All right. Let's carry on with this recording and see if there's more questions from George here. Okay. Now, when you're flushing, though, on the end, you can use whatever. You can go up to 500. Go disinfectant. Which they 500 parts per million.
Yes.
Medical grade disinfectant.
Just gotta get this.
Yep. Yeah. Right. He's just getting a phone call there, so let's carry on with that. Move that forward.
Okay, perfect. See that.
Yeah, and I can also send you all the studies you want, videos, etc. Validates avian birds. somehow figuring out fogging, right? And if you're fogging in regularly, a video of a man in the U.S. who is fogging 500 parts per million and just standing there with his face, breathing it in. That's
with the HO,
with HOCL. Legally, there's that, and there's if your barn is going to come in and measure. Don't want to talk about that. Okay, so the other thing that George had mentioned was that we talk about 90 degrees, we talk about 45 degrees, that you talk about in some areas about using PEX and actually having nice curves rather than 45s or 90s in some
angulars,
locations.
right?
Obviously, the more places you can use curves, the better it is in terms of, And Absolutely. Then I talked about placement of a vortex generator. As a general sense, placing a generator immediately prior to a 90-degree bend is kind of counterproductive. It would be better to place it after the bend or after, so that the water going to have undisturbed however the water, that's not going to get deteriorated through the bends. So
yes,
okay. All right. Do we have another questions here? Yeah, that one we got.
If you have water with a really, really high content and you run it through an RO system and it becomes really aggressive, it starts attacking or looking for minerals
because you've taken the minerals
out. How does vortexing placate the water since it's not replacing?
Okay. It's not putting them back in. So we've got that. So those questions from this gentleman. We're nearing an hour, but we can maybe talk a little bit more about RO. In general, how would we determine where the best placement for devices is? Say, for example, like when I thought the discussion about the well, drilling a well, and already now we're bringing up immature water. Okay, let's call it immature water. And so would that suggest that literally the pump that's being used to draw the well water should have a vortex generator? Because then that water is being distributed throughout the various infrastructures in the colony. How would you determine the best place to locate generators throughout the infrastructure?
As a rule of thumb, it's better to have, what you want to do is to have water near to the point of use, first of all.
The further out, say so the further you install them, the better it is.
Yeah, now that's use. There's also the matter of the need for that water. So, for example, if you've got a pump, you've got a distance, and in that distance, well, now you've got some land that you're growing on, that you've got animals and stuff like that. Well, at the pump now, having one on the pump or wherever you have it is going to keep that water in a higher active and coherent state, and therefore it's going to have less deterioration on the infrastructure itself. That includes any heaters, that includes the pipes themselves, because generally speaking, agglomeration or scale buildup is not going to occur. That's going to make those pipes last long, long, long. And so on the system itself, depending on you determine, it's like, oh, let's do what we can to get someone to put one on. But we weren't looking at the system itself. You look at the size of it, the flow rates, the line size itself, points of diversion, where you want to, near. You might also even design bypasses at the time. I've got a unit on in Idaho on a 10-inch line. That thing's going on into its 9th or 10th year. I don't think it's ever been offline. And so thinking about making bypasses and stuff like that, he did put a fresh coat of paint on it a couple of years ago, so it's been spruced up. But ultimately, they are, and the ones that we have now, he's got an old design, but the designs we make now have been improved. We've learned a few things to get even more out of them.
Right. So circling back to the RO question again, so can you talk a little bit about how the obviously the in surface tension
Okay.
is going consumption of energy, the pumps itself. If I remember correctly, you mentioned about one client that the ampere pumps was drawing 34, and after installing Vortex generators, that was down to 27 amps plus or minus. So the reduction in energy cost, the reduction in water. I've heard different numbers thrown around with vortexing as high as 40% reduction in water. Is that to expect that high of a reduction in water usage?
Well, it depends on use. We have one customer who had a 75% reduction in what he actually needed, and his proof. In this particular case, he had a paddock. He had cattle that were grazing. He started with 15. He went up to 29 cattle to graze the grass, and the 29 couldn't keep up with it. So then he started reducing. He was reducing the amount of the times of water, and he was going from essentially millions of liters. He talks about liters to, I mean, it was math. It was like a 75% reduction. Now that was him.
Right.
And the other proof of it, the visual proof, Jody went out to see him. We got him on video. Dean Sanders is his name. And the proof of it as well, Dean told Jody, this time of year, my paddocks are empty. And then he turned around and showed one was totally full, the other was half full. He used
Empty in terms of
75
forage?
in terms of how much water he had left compared to
Okay.
what he had allocations. And
Oh,
so
okay.
if the water was gone, it was gone, and that was enough
Right.
said. Sitting there with 1.5 paddocks of water, 75% reduction.
Okay, so they allocated water allocation, and he needed to use less of that water, 75% less of that water.
That's right. He didn't have the need for it.
Got it.
So therefore, he started just going a week without watering it at all,
Okay.
because the cows wasn't keeping up with what he was doing now. I mean, and he said that the grass was sweeter, and so they went after that, and they were satisfied.
Right.
So
And
it all
then,
depends. Yes.
no, go ahead.
Oh, I was just gonna say we're all snowflakes here.
Hmm.
We want us on something that we can apply to everything and everyone, and I say don't do that.
Right.
Let's get in the moment and let's see what do we have here now. What's happening?
Right. Right. Yeah. So so energy reduction in water use. What about the reduction in chemical inputs or fertilizers, nutrients? If somebody's growing various nutrients, even in controlled environmental agriculture, like in greenhouses, etc. How would you address? First of all, we assume there's going to be a reduction in nutrients. How would you start scaling back the nutrients? Because if you don't scale back the nutrients, you're going to overdo it, right?
Well, that is a possibility for sure. The rationale for scaling back is efficiency. You have
Right.
smaller cluster sizes, you have less energy needed to deliver, you have a better, more effective to penetrate root walls, for example, if we're talking agriculture.
Mm-hmm.
And therefore, the other thing, when you consider that your existing water is the one that's inefficient. So people are used to paying what they've paid. They're used to consuming what they've consumed due to the fundamental inefficiencies of the water they already have.
Right.
So that includes the higher surface tension. That includes the higher sizes. Includes the proclivity to agglomerate. And so that's your investment in fertilizer, feed, whatever it is, it falls out of suspension and sits in the pipes.
Hmm.
You also have water, for example, even in irrigation, where when that water is not coherent in this respect, the evaporation rate, they could call it evapotranspiration. The evaporation rates are faster. The freeze and thaw rates are different. And so you can have water that is so unstable that when it comes out of the irrigation, and to the extent that you have it up there in Canada, it can come out of the nozzle and just evaporate into the air. Vortex water is more stable in that respect too. And so what comes out of the nozzle, more of it is going to get on the leaf if you're doing foliar sprays. More of it is going to get in the ground, and it's going to have a higher oxygen density to it. You got a lot of different things. It's not a one factor.
Right.
It's a many factor.
Affecting many things. Yeah, exactly. So,
Mhm.
and then as far as reverse osmosis filtration, it's a very common problem and having to change the membranes very regularly. How can vortexing water address that?
Well, clearly, installing a vortex unit on the inlet side of the RO system will actually break that stuff up. The, we motion, but is that motion also makes certain amount of work done. I'm talking physical work. And because water is incompressible, and in conjunction with the shape of the cavity that our units are with, in addition to the elements that are inside, you've got an incompressible solution called water, and it's carrying all that stuff called solids. And because it's creating these flows, some of the flows in a vortex literally go in opposite directions to each other simultaneously. These are laminar flows. And my fingers are, going in linear fashion, but they're actually circular. So you have one flow that is going from the inside out radially, and you have the other flow that's going from the outside in, and they call it, well, the radial side is connected to or associated with what they call explosion radiation. Okay. The inwards is implosion. You've got flows that are going in toward the center, but they are alternate one to the other. So those solids that I was talking about, when those solids, they get caught up in those flows, and the water is not compressible. And so those solids get ground down, and then they get distributed throughout the volume itself. That's where the colloidal state is created. That's where your bioavailable availability stuff. This is where those elements, which are not solids per se, but these elements can now actually be converted and changed into something that is usable by the recipient. This is how they go through the membrane instead of getting clogged up within it, costing you more and more money as a consumable, but actually you still need the elements.
Right.
So it's delivering the elements that are actually necessary to do what you actually need to do and need to get done. So this is enhancing your investment in everything, and it's also, due to those efficiencies, allow you to get not more from your investment, but actually what you invest in for less, because you want the end result is what it is. It's not that you simply want to buy feed. You want what the feed does.
Right.
Okay.
Okay.
So
Good then.
all right. So I think this conversation is probably of very little interest to anyone other than us and the people who listen to it. So it'll probably go private after we're done, and then I'll send you a link to it. And we could also, we can do some experimentation with the and do stuff like that. But anyway,
Okay.
that's some good stuff. Still, that's useful stuff. I'm happy to say.
Yeah, I would say that it's still, a couple of colonies that we spoke about today would be interested in this.
That's
So,
good enough for me. Right off.
I have to imagine. So if we'll send them this link, so you can stop the recording now, though.
Yeah. So bring it down. Boom.